Hi everyone, this is Fahad Mirza and I welcome you to the channel. In this video, I am going to show you yet another RAG tool called as dsRAG. We are going to install it locally and then we will test it out on one of our local documents in terms of RAG. But before that, let's try to understand in a very simple way what exactly is RAG and specifically what is this dsRAG project. When it comes to RAG, all it does is it provides context about your own data to the large language models. Just imagine that you have your own private data stored in PDF files or text files or any other repository, and these bits of information are not known to your language models. No matter how performant the model is, it simply doesn't have a clue about your own data because it was not trained on it. If you want to provide that source of truth, that grounded response, that context to the LLM from your own data, you need to do either fine tuning of that LLM or do the retrieval augmented generation or RAG. What happens in RAG in simple words is that you take your data, for example, a PDF file, you divide that PDF file into smaller pieces called as chunks. You convert those chunks into numerical representation or embeddings with the help of an embedding model, and then you store those embeddings in a database called as embedding store or vector store. Vector is another word for embeddings. Once that data is stored, whenever a user comes in, asks a query from the LLM about your data, the RAG pipeline kicks in. What RAG pipeline does is it makes a similarity search on the basis of user's query into your vector store or vector database. From there, a response is returned, and optionally, another model ranks the responses in terms of how similar they are to the user's query and then returns the top results. And then that result is appended or joined to the user's query and then given into LLM. Now LLM uses its own intelligence and the data which is appended to the prompt to give back a more grounded and context rich answer to the user. So this is what RAG is. Now enters this new project called as dsRAG. dsRAG is a retrieval engine for unstructured data. Unstructured data is a very loose term. It could mean any sort of file. It could be a free flowing text file, PDF file, or anything like that. Normally, what happens is that when we store our data into such as relational databases in form of tables, rows, and columns, that is called as structured data. Unstructured data means when, for example, in PDF file you have paragraphs, you have images, you have tables, lot of stuff are there. There's no defined structure, so that is called as unstructured data. dsRAG aims to tackle the complexities around that unstructured data. And by the way, once we install this dsRAG, we're also going to use one PDF file with unstructured data to see how it works. dsRAG is quite good at handling challenging queries over dense text like financial reports, legal documents, or academic papers. It also has achieved a lot of good performance on various benchmarks. Not only that, they have even defined their own benchmark called as KITE. And I really don't remember what KITE stands for. If I remember vaguely, I think it has to do with some knowledge intensive tasks, something like that. But you can find that information about the kite and that stuff in their GitHub repo, and I will drop the link to that in video's description. So what happens is that in very simple words, what they do something called as semantic sectioning, then auto context, and then relevant segment extraction. So these are the three key methods they use to improve performance over other RAG systems. Very quickly, when we say semantic sectioning, what it does is it uses a model to break a document into sections, and then it works by annotating the document with line numbers and then prompting an LLM to identify the starting and ending lines for each semantically cohesive section. Then there is an auto context that creates contextual chunk headers that contain document level and section level context. And then comes relevant segment extraction or RSE, which is a query time post processing step that takes cluster of relevant chunks and intelligently combines them into longer sections of text that we call segments. I think it is better to try it out instead of going into the theory, because you can always read it through in the repo, and you can find the link in video's description. So let's go and try to install it. Before I do that, let me give a huge thanks to our good friends at Mass Compute who are sponsoring the VM and GPU for this video. If you're looking to rent a GPU on very affordable prices, I will drop the link to their website in video's description. Plus, I'm also going to give you a 50% discount coupon which you can find in video's description. This is my Ubuntu system and this is a GPU card, NVIDIA RTX 6000 with 48 GB of VRAM. As usual, to keep everything nice clean, let's create a virtual environment with Conda. And now let's install our dsRAG. It's a simple pip install which installs a lot of other auxiliary packages too. So let's wait. And by the way, I will be using OpenAI's model with it, both for the LLM and for the embedding. By default, it uses OpenAI's model for LLM and Cohere's model for embedding. But I don't have the Cohere's API key, so I'm just going to go with OpenAI's models. And I really don't see any option of using any local models as of now, maybe in the future. So if you're also following along, go to platform.openai.com and grab your OpenAI's API key from there. That's a paid option. And that is installed. Let me set my OpenAI's API key and then I will clear the screen. And now let me launch my Jupyter notebook and we will see this in action. And now let me import the libraries which we have installed plus instantiate our LLM with this GPT-4o mini model. And as OpenAI doesn't really support any re-ranker model, so we are not using it. But if you're running a production grade pipeline for RAG, I would highly recommend that you use a re-ranker because it really greatly improves the return results from your vector store. And the model is instantiated. Now let me specify the knowledge base, which is a persistent store where it stores all the data. So what I'm doing here is I'm just creating this knowledge base with the LLM which we have defined above from OpenAI. We are not using any re-ranker and we are just assigning it to our knowledge base ID. This ID, because this knowledge base remains persistent on the disk, that is why you can even call it from other scripts in the future. You don't have to create it again and again. And this is a file from my local system which I'm using. You can even put in a text instead of a file, and then from there, this is primarily a PDF file. This is the one. It has some of the images, it has some of the other characters and lot of stuff. So just 3 pages. And then that paper is about something called as Llama Fusion, which is a new concept, and that is what I am asking it, because otherwise this LLM has no clue about what Llama Fusion is. That is why I am providing this file which has a grounded answer, and then I am querying from this document or this knowledge base this question, and then returning and printing the result. So let me run it. And there you go, we have our response. So it added one chunk to the database, to the knowledge base. And then this is the grounded response. It has returned about that Llama Fusion, that it's a framework that empowers text-only LLMs that with multimodal capabilities. And it has obtained that information from this paper, which I have just put it in here. So you see, this is really cool stuff. The speed is quite good. The performance is quite good. Now I think there is also some support for Olama in pipeline, so I will just wait for it to get bit more mature in that sense, and then I will also be creating a video around dsRAG with Olama. But so far looks really promising. Let me know what do you think about this tool. If you are interested in learning a bit more about RAG, I have done like hundreds of videos on RAG in the last 2 or more years, so please check it out. If you like the content, please consider subscribing to the channel. If you are already subscribed, please share it among your network as it helps a lot. Thank you for watching.